Hello, geometry students. We are going to talk about how to actually use trigonometry today. So, in the lessons leading up to this, we defined three trigonometric ratios: sine, cosine, and tangent. And all we did with them was define them and then write them out as fractions, but we didn't really use them for any purpose. We just said, well, sine is opposite over hypotenuse. So, if you have the opposite and the hypotenuse, you can write the sine fraction. That's not the point of trigonometry, though. The point of trigonometry is to use that stuff to be able to solve for other things. And that's what we're going to get into today. So, we are going to today use trig ratios to find some side lengths, but I need to give you a little bit of backstory. So, first thing says, what's the relationship between these two triangles? Well, they kind of look alike. One's bigger than the other one, but you know what I realized? They're both 30, 60, and 90, which means they have three pairs of congruent angles, which means that these triangles are similar by angle-angle similarity. Okay, because remember, if two triangles have the same angles, then they're similar. And then it says find the ratios for sine A and sine D and reduce. All right, so sine A means look from the perspective of A, do opposite over hypotenuse, and I get 1/2. And then if I do sine D and I do opposite over hypotenuse and then reduce, I also get 1/2. And the A and the D have a 30 on it, right? So it seems like the sine of 30 is 1/2 no matter what. So let's check that out here. So if I pull up the calculator, I'm going to type in sine 30 and see if the calculator, even without a triangle to look at, also thinks that sine of 30 is 1/2. Hint, it does. Pardon my yawning. All right, so trig sine 30. And look at that. That says 1/2 as well. So what I've learned from this is that the triangle, yeah, it matters to help set up the ratio, but if I know the angle, I don't need the triangle at all. And in fact, for every right triangle that has a 30-degree angle, the ratio from the opposite to the hypotenuse is 1:2. Okay? So it says, would this also work for cosine and tangent? Well, of course it will, because the ratios of the sides are the same in any similar triangles. So we're going to say, of course, the ratios of the sides is consistent because the triangles are similar. So when triangles are similar, trig ratios of corresponding sides are equal. And in a nutshell, that means sine of 30 equals sine of 30, no matter what triangle you're looking at. So then why are these helpful? Well, they're helpful because if sine of 30 equals sine of 30 no matter what, then if I have a triangle where I don't know the opposite and the adjacent and the hypotenuse, I can find them using trig. And that's what we're going to do. All right. And a lot of times this is called indirect measurement. And if you wanted to know, well, does anybody use this in the real world? Absolutely. If you've ever been driving down the street or riding in a car down the street and you see those guys with the tripods at the side of the road looking through what looks like binoculars, they are often doing height and distance measurements using angles in trigonometry. Okay, so that stuff really comes into play a lot there for indirect measurement. All right, so this says to measure the height of a tree, Anna walked 125 feet from the tree and measured a 32-degree angle of elevation from the ground to the top of the tree. Use a trig equation to calculate the height of the tree to the nearest tenth. So if I want the height, I want x. Now, if I want to find x, I have to think about my options here. Well, option one is that's a right triangle. I could try Pythagorean theorem. Yeah, that's not going to work out so well because I only know one of the sides, and I would need to know at least two of them to get Pythagorean theorem to work. So that's out, and I don't have any other way to find that side. Enter trig to the rescue. What I do is I say, well, you know what? From the perspective of this 32 degrees, this is the opposite side, and this 125 is my adjacent side. Well, what trig relationship uses opposite and adjacent? Tangent does. So the tangent of 32 equals opposite over adjacent. Now I have an equation. How do I solve this equation? Well, it depends on where the x is. All right. Whenever you want to solve any equation, you want to think about what's happening to x and undo it. So if I want to solve for x is being divided by 125 to undo division, I would multiply. So I'm going to multiply by 125. And then on the left-hand side here, I have 125 times tan 32. I don't know what that is. The calculator does. So in the calculator, I'm going to type 125 times tan 32, and it's 78.1. So x is 78.1 feet. That's a tall tree. And there you go. That's how trig is used to find sides. You just set up the trig ratio based on what you have, and then you solve for x. Let's do it again. Oh, there's stuff on this page. Pretend you don't see it. Da, 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 da. I thought I deleted this. It must have come back. Okay. So a 20-foot wire supporting a flagpole forms a 35-degree angle with the flagpole. To the nearest foot, how high is the flagpole? So again, indirect measurement to figure out the height. So from the perspective of 35, the x that I really want is the adjacent side. That 20 is across from the 90-degree angle, so that's my hypotenuse. So then I think, all right, what trig relationship relates adjacent to hypotenuse? Well, that's cosine. The cosine of 35 equals the adjacent side over the hypotenuse. Remember, whenever you write out a trig function, sine doesn't mean anything unless there's an angle next to it. Sine x has meaning. Cosine 35 has meaning. If you just wrote cos, it doesn't mean anything. It's like just writing down this. Great, you have a division sign. You can't do anything with it unless there's numbers or letters attached. So anyways, cosine 35 equals x over 20. Well, I got to solve for x. X is being divided by 20. So I'm going to multiply by 20. So those cancel. And I get x equals 20 times cosine 35. And I will put that in the calculator. 20 cos 35. 16.383. It says to the nearest foot. So if I went around to the nearest whole number, that would be 16 feet. Let's do it again. Solve for x and y to the nearest tenth. Well, I got to do one at a time here. So if I want to do one at a time, I'm going to go from the 26. X is opposite. 14 is hypotenuse. So sine 26 equals x over 14. I will multiply by 14 and get x equals 14 sine 26. 6.1 to the nearest tenth. But I was also supposed to find y, and y is the adjacent. So if I look adjacent and hypotenuse, that would be cosine. Cosine 26 equals y over 14, adjacent over hypotenuse. And then I multiply by 14 again. So 14 cosine 26 is 12.58, which would be 12.6 if we round to the nearest tenth. And there we go. Now, one thing we can do to check our answers, just to kind of tie all this up in a nice, neat bow, is say, well, you know what I just found? I just found out that this is 14, because they told me, y was 12.6, and x was 6.1. If that's correct, then a squared plus b squared should equal c squared. Let's see if that works. So now it's not going to be exact because we rounded, but 6.1 squared plus 12.6 squared. And I want to see if that equals 14 squared. 195.97, 196. It does. I'm pretty confident in my answer now. All right, now we have to draw our own diagram. A radio tower is 250 feet tall and requires 4 guide wires to support it in case of high winds. Safety standards state that each guide wire must form a 65-degree angle with the ground. How long will each wire be? All right, so a radio tower, so here's our radio tower, is 250 feet tall, and it has to have 4 guide wires. So if a guide wire goes from the top of the tower to the ground, and it makes a 65-degree angle with the ground, and I want to know how long each guide wire is going to be, that would be my diagram. And so from the perspective of 65, this is the opposite. That is the hypotenuse. So that's sine 65 equals 250 over x. And now if I want to solve for x, x is on the bottom of a fraction, and that's no good for me. So I'm going to multiply both sides by x so that I can eliminate that fraction. So then I have x times sine 65 equals 250. Well, x still isn't alone yet. X is being multiplied by sine 65. Well, I want to get rid of that, so I'm going to divide by sine 65. Because to undo multiplication, I divide. So 250 divided by sine 65 is 275.8. They wanted to the nearest tenth. That's what I gave them, 275.8 feet. There we go. Okay, down here it says in the diagram triangle ERM is similar to JTM. If I know that those are similar, then I know that the angles are the same. Angle E is the same as angle J. Angle R is the same as angle T, and the M angles are both 90. Which statement is always true? All right, well, cosine J equals RM over RE. So let's see. Cosine J would be adjacent, JM, over hypotenuse, JT. All right, well, that doesn't seem to work. Let's see, what else? Cosine R equals JM over JT. Well, cosine R would be adjacent to R, that's RM, over hypotenuse, that's RE. That doesn't seem to work. Let's try again. Tan T. Well, let's see. T is right here. Tangent is opposite over adjacent. That would be JM over TM. Nope, that doesn't seem to work. Now let's try tan E. Tan E again would be opposite over adjacent, so that's RM over ME, opposite over adjacent. That's not it either. Now, I'm playing this up here. I do know what's about to happen, but I wanted to show you that at first it looks like none of these are correct, but you know what we didn't do is we didn't consider the fact that like cosine J would be the same as cosine E. Cosine J would be the same as cosine E because J and E are the same angle. So let's see, is RM over RE cosine E? Well, cosine E would be adjacent and RM is opposite. So this is definitely not it. All right, let's try cosine R. Well, R is the same as T. Is cosine T going to be JM over JT? Well, cosine T wouldn't start with JM because that's opposite. and I want it adjacent. All right, tan t. T is the same as r, so I want to know if tan t is the same as tan r. Well, tan r would be opposite, which is me. Nope. And then tan e. Well, e is the same as j. So maybe this is the same as tan j. Tan j would be opposite, tm, over adjacent, jm. Hallelujah. We finally found the answer. Now, that's more than I really need you guys to completely understand. All right, that's just a creative way to remind you that when we have similar triangles, their trig ratios should match up. Okay. But in a nutshell, what I need you to be able to do is solve for sides using trig. And that's what this homework does. It says you're going to look at these pictures and you're going to say, okay, if I want x from the perspective of 32, x is the opposite, 18 is the hypotenuse. So I know that the sine of 32 equals x over 18. And then you solve for x. So that is it. I want you now to practice this homework assignment. If you have any questions, you know you can reach out to me. I hope that made sense. Have a good day, everybody.